All right, we're going to look at multiplying and factoring today. First, let's do a quick review. This is from way back in Module 1. We're going to review what we do when we have two of the same base being multiplied together. So this just means we have an n, and this means we have an n times n times n. Well, if we're multiplying that all together, we really have n to the fourth power. If we recall, this is a power of 1. To put a 1 and a 3 together, we're certainly not going to multiply them, we're going to have to add them. So when we have like bases and we are multiplying them, we want to add those exponents together. So we needed that in order to do these. What we're going to do now is a distributive property with polynomials. You've done similar things before, but there's going to be a lot more variables in here now. So we want to take the 5n and distribute to the 3n to the third. Then we want to distribute to the next piece and then to the next piece. So first off, 5n times 3n to the third. Now, I wouldn't write this down if I were just doing the problem. I just want to write it down so I can show you guys. 5 times 3 is 15. I just did n times n to the third up here, so that'll give me an n to the fourth. Next one, we want to take a 5n times a negative n squared. Well, 5 times negative 1 will give me negative 5. N and 2 n's gives me 3. And then one more, 5n times 8, that's going to give me 40n. And that's it. That's all we're looking for. Now, that's if we're asked to simplify by distributing and get rid of the parenthesis. Next, we want to find the GCF, and then we're actually going to factor the GCF from a problem. So GCF, really, if we break it down doing the prime factorization, we are looking for the stuff they all have in common. And eventually you guys will be able to just look at this and say what they all have in common. But for now, I'm going to show you process. 3x to the fourth. This is 3 times 3, and then 2 x's. And then this is 4 times 3, which also breaks down to 2 times 2 times 3, and an x. So we are looking for what they all have in common. They all have a 3. They also all have an x. And that's the only thing they all three have in common. Now, these two have an x, but this one doesn't have another x. So we got a 3 and an x. And that is your GCF. Remember, we want what they have in common. What they all have. All right, the reason we need to know that is so we can do the next step, and that is to actually factor the GCF. This just said to find the GCF. Now we're being asked to factor the GCF. This is, in my opinion, the reverse of the distributive property. Okay, we are undoing the distributive property. We're figuring out what we can put in front of the parenthesis and then what will be left over for each piece. So if I were to go back and do the process of breaking this down and breaking this down and breaking this down, the thing that I'm going to have in common for all of them is a 3 and 2 x's. So the reverse of the distributive property, well, when we distribute, we multiply. The opposite of multiplying is dividing. So we're actually going to be dividing by 3x to the second on each one of these. Now, how did I get the 3x to the second? I went through a process like this to figure out what the common denominator was, what the greatest common factor was, rather. All right, so when I'm dividing here, 9 divided by 3 is 3. X to the sixth over x to the second. Remember, when we are dividing, we subtract those exponents, so we'll have 4 x's left. Now, if you think about this, when we multiply this back together, we're going to have 3 times 3, or 9. X to the 2 and x to the 4 makes x to the 6th. Okay, so we didn't really change it any, we just kind of broke it apart. Why are we taking this out? Because this is what all three terms have in common. So this is what can come out of all three terms. 15 divided by 3 is 5. 4 of them and 2 of them reduced down to 2. And then the last one, 4, there is no x because both x's cancel. X to the second over x to the second is just 1. So this is your final answer. This is the GCF, and this is what's left over after dividing the GCF out. Now I am going to do one more of these. See if I have room on the bottom of this paper here. All right, if we break these down and figure out the common thing, they are all going to have a 6 and an x to the second. But they also all have something else, especially the largest term. They all have a negative, so we're actually going to factor out the negative. Okay, anytime our lead term is negative, we usually want to factor that negative sign out with it. So our GCF is what we're dividing by. How did I get the GCF? I broke these all down. I looked at what they had in common. Simplify here, I'm going to have x to the second. Two negatives, that's going to be positive 3x. And then again, this is going to be positive 2. So what's left from the first term, what's left from the middle term, and what's left from the last term when I divide that common GCF out?